experience. If you guys can let me know. Let us now talk about the first session, the morning sessions. That's been taken by Shiv sir, right? And I hope you people are attending those. So among the people present now, tell me how many of you have been attending the classes, early morning classes conducted by Shiv sir. And also do let me know if it's the first class of someone, the first class. Guys, let us have a two-way communication, huh? So that will make things easy. Let me share my screen. Guys, just confirm if the screen is visible.
Yes, sir.
Visible, right? So basically in this session, let us try to cover up these three algorithms. Okay. And I hope one or two of these have already been covered up. We'll just have a revision of them. The first algorithm is to determine whether a number is prime. Prime number algorithm, I believe this has been done by Abdul sir, right?
Yes, sir.
Okay, if any one of you wants me to repeat this, then we can go ahead. We can just have a walkthrough on algorithm. Okay. Any of one of you can just tell me what a prime number is? Just a simple answer. A prime number.
A number which is divisible only by itself and 1.
A number which is divisible by only itself and 1. That's right. Numbers. Well, let's suppose these are a few examples, and as rightly said, prime number is the one which is only divisible. Divisible, what do you mean by divisible? That means the remainder should be 0, right? Prime number is a 1 which is only divisible by 1 is 1. The second thing is itself. So if we find a number which is also divisible by except for these two things, that is 1 and the number itself, if there is a number which divides the prime number, which divides a number, that means it's not a prime number. Okay, let us take an example 6. Okay, Let's suppose we take an example 6. So 6 is divisible by how many numbers? Okay, let's start from 1. Let's start from 1. Obviously, it's divisible by 1, right?
Yes, sir.
All numbers are divisible by 1. There is no number which isn't divisible by 1. All numbers are divisible. So let us add 1. And also, it is divisible by itself. Okay, a number is always divisible by itself. So these two conditions are out now. Next, apart from 1, is there any number which divides 6?
Yes, sir. 2, 3, both.
Right? So, even 2 divides 6.
Even 3.
2, 3 times is 6, right?
Yes,
So, next 3. 2 times is 6.
6.
Is there any other number? No, right?
No.
So since 6 is divisible by, we can neglect this 1 and 6 because it's obvious that it's going to be divisible by 1 and itself. But the number 6 is also divisible by 2 and 3.
2 and 3.
Therefore, what can we say? We can say that
This is not prime number.
6 is not a prime number. I hope you guys are getting it, okay? We have 6 people. Next, let us take another example. Let's say 10. So 1 and 10 is obviously definitely it's going to be divisible. It's going to be divisible by 1 and itself. The next number, is it divisible by 2?
Yes.
5 times, right?
Five
Next,
times.
next what would be the number? Is it divisible by 3?
No.
No.
Divisible by 4? No.
No.
But 5?
Yes.
Divisible by 5. 5 2s are 10, right?
Yes.
Next, is it divisible by any other number?
No.
Nope.
And also, one thing you can notice here, the range that I am taking in, right? For the first example, 6. What is the range that I've gone from? I've started from 1 and
6.
I've gone until 6. I'm not going beyond 6, right?
Yes.
This is just, to let you know like how we'll build the algorithm. This is helpful. We need to know what is the range that we're supposed to take. So since it is 6, I'm going from 1 to 6. And so it's the number that I'm verifying if it's prime or not. It's 10. I'll go right away from 1 to 10, not beyond 10. Okay. So that will be my loop, the looping, the repetitions. Okay. That will be my repetition. Okay. Apart from 5, next 6. Is 10 divisible by 6? No. Not even 7, not
No.
even 8, not even 9. And finally it's 10.
10.
Now, if you see 10, it also has apart from 1 and 10, it also has 2 numbers, 2 factors we can say. 2
2 and
factors,
5.
2 and 5, which divides completely 10, right?
Yes.
If you see the remainder, that will be 0. Okay, one more thing you need to do. 10 mod of 2. What will this give? This will give us, the remainder is
0.
0. And also the next term, 10 mod 5. This is also going to give us 0, right?
Yes.
Because of which 10 is also not a
Prime number.
These are just a few examples. Now let us take a few examples which are prime out of these things, right? You can see 2 is a prime number to start with. 1 is not a prime number, okay? You can always begin with 2. 2 is a prime number. 2 is not divisible by any other numbers, right?
Yes.
3 is also not divisible by any other numbers. You see 5, right? 5 is also not divisible by any of the numbers. 7, 9, 11, 13, 12, 29, 41, okay? All these numbers, they are not divisible by any of the numbers apart from 1 and itself. So these numbers are said to be prime numbers. 2, 3, 5, 7, 9. Is 9 a prime number? Right?
No.
No, right? Hence it is divisible by what's the number that divides?
3 and 3 is a 9. 3. Sorry. 3
3
3
threes are 9, right?
3
Yeah.
3 is a 9.
Also 22.
22 also.
It's
2 1.
no, it's
Is it a
not.
prime number?
Not
Right?
prime number. Not prime number.
11 twos are, right?
11 twos are.
29, definitely it's prime number. You tried, like you can take a range for 29 right away from 1. Okay, since you now know that the range that we are going to take, it is not going to include 1 and the number itself. So what is the range that I'll have to take is, I'll begin with 2. Okay, you guys understanding this?
Yes, yes.
I'm not going to take the first 1 and the number itself. So my range will begin from 2, 3, 4, 5 and up to 28.
20.
Okay, so this number is 29. I'm not going to go until 29. Why? Because 29 is, it's obviously it's divisible by itself, right? So this is going to be my range. I'll pick each number once. Okay, the iterations or the repetition how it's going to be within our algorithm is, I'll take the first number, that is 2. I'll see if 29 mod 2 is equal to 0. I'll see. Will this be equal to 0?
No.
No, right? So what
No.
I'll do? I'll repeat this. I'll go to next number. Next number is 3. Is it divisible? No. I'll go to next 4. So this way, I'll complete the complete loop. I'll
20.
go through from 2 right away from 2 to 28. Since it isn't divisible, finally what I will do is,
Reminder
once I
is
come out of the range, that is 28 is my last number. So if I cross that and go to the next iteration, that is 29, at that time what I will say, no, the range, we are coming out of the range. So now since we did not get any number which divides 29, okay. So since because of that 29 is a prime number. Clear, right?
Yes.
Can we begin with the algorithm? This is the basic spec,
Okay.
differentiating between prime number and a number which is in prime. Okay. So let me clear this. Let us try writing the algorithm. Okay. What's my first step is going to be, since you guys have already been, writing a few of the algorithms. The first step.
Start.
Yeah. So always my first step is supposed to be start. Next step.
Declare the variable.
So see, first thing is I need to take the input from the user or
Input,
from the
okay.
system, right? Because I want to know what is the number that I need to see, like if it's a prime or not. So first I need the input, right?
Okay, right, correct.
Okay, for in like a high level English, I'll write this also for your understanding. Accept a number. Okay, accept a number. Okay, now let us say you read the number or you take input as that number and let that be num. Okay, I'm declaring it as num. You can declare it whatever you want. You can declare it as n. You can declare it as num number. It's based on you. Okay, that doesn't have anything to do with. So the first thing is we are accepting a number. Okay. Next, now we have a number. Now what are we supposed to do? See. Okay. What did we do? We did iteration, right? We repeated a few things, right?
Okay.
We had a range and we repeated. We looped through it one by one. We just kept on looping, and we, there was one condition, then we checked. Okay, this 29. What is this 29? 29 is 9. 29 is nothing but our num, right? It's our number, the input number. And modulus, it's going to be remain same. And we have one thing that is getting, like iterated. So let us call that as I. Okay.
Iterated.
Because it's going to be iterated from starting from 2 until the last but 1. Right. If it's 29, so we are looping from 2 to, we are going up to 28.
28.
Right. So let us take that as I, iteration. Okay, this is supposed to be one of the conditions. So in the step 3, I need to iterate. I need to repeat a few steps.
Okay.
And for that, what is my condition? If you remember, let me see if you remember. I said at one particular time I am going to stop it and I'll like say whether it is prime or not. So what was that condition? If you listen properly, you'll give me the answer. There is one condition until which we'll iterate. Once we reach that, we are going to stop the iteration. So what is that condition?
28. 29.
29. So okay, that is in terms of number. So why 29? Can you put that into a statement, into a condition? 29, right? Okay, let us take one more example here. Let me say 11. So what am I going to do? My range is supposed to be, let us forget about the range. We'll start from 2 itself. We'll have 3, we'll have 4, we'll have 5, we'll have 6, 7, 8, 9, 10. Next, am I going to have 11 too?
No.
No.
No, right? So I'm not going beyond 11. I'm not going beyond 29. So what is
Yes.
11 and what is 29 according to our algorithm?
Prime number.
The input, right? The input that we have taken.
Please.
Getting my point. See, I have highlighted it in the,
If the prime number is 0.
see. What is this 11 and what is this 29 and what is this 6? What is this 10? It is nothing but the number that we are taking. It's the
Yes.
input number, right? So what I'm doing, I'm not going beyond that number. My range is not going beyond that number. Okay. So in terms of conditions, what I'll say is my iteration, what is my iteration variable?
0.
No, variable.
Variable is.
What have I taken my iteration variable as? It's I, right?
I.
I is my iteration. Most often we are going to use this. Okay. Most oftenly this I will be used as an iteration variable. So just keep that in mind. Iteration.
Is there any specific
variable.
reason for that?
No. It's like, it's common in programming language.
Oh.
Basically we take I, J, we take these in the loops, we declare them as variables in loops. Okay. And num is nothing but my input variable. Input variable. Okay. So these two things are clear, right? I is supposed to be my iteration variable and number is my input variable. Input variable. Now the condition that I'm going to check is nothing but I'll see I will see if I, okay, is lesser than n. Okay, I'll go only until this condition. I is less than n. Initially, what was I? See, I will put that here.
0.
See, no. I. You see, I told you, right? We are going to start with 2 because we are going to exclude 1 and the number itself. So my I will by default will be equal to 2, not 1.
Okay.
I'm starting with 2, right? I'll ignore. I know 1 is the number that I'm going to check. It's definitely going to be divisible by 1. So I will ignore 1.
Okay.
And also I will ignore 6. If it is 10, then
Itself.
I will ignore 9.
Okay.
Okay. So Those are not in my range now. I am ignoring them. Apart from these two numbers, if there is any number which divides this number, then we can say, no, this is not a prime number. Got it? Or I went too fast?
Yes, sir.
Apart from 1 and the number itself, if there is any other number which divides our prime number, that means it is not a number. Okay. So for 6, apart from 1 and 6, there are two numbers, that is 2 and 3, which divides 6. Therefore, 6 is not a prime number. For number 10, for our input number 10, apart from 1 and 10, there are two numbers, 2 and 5, which divides 10 completely, because of which 10 is not a prime number. For 29, apart from 1 and 29, there is no number between this range, that is from 2 to 28, there is no number which divides 29, because of which 29 is a prime number. Okay, so the looping is the condition that I'm going to check, that is supposed to be I should be less than n. Until and unless I is less than n, I'll continue iterating. We'll take this itself as an example. Okay, we'll take 29 itself as an example. I is supposed to, my I is going to start with 2 and my number is nothing but 29. In my case, I'm taking input number as 29. Okay, and I is supposed to start with 2. And I'm not going beyond my number, right? I'm not going beyond 28. I'll only loop until 28. So what I'll do, I'll check the condition if I is less than n. Okay, once I complete the algorithm, you will understand why we are putting this here. Okay. Until I is less than n. We are going to repeat a few steps. Okay, let us see what those steps are supposed to be. Step 4. One condition is satisfied. Let me say, let us start our algorithm. I've started. Step 2 is we take a number, input number as num. Okay, we have taken 29 as our number. Now, and also we have declared I. Okay, we haven't declared I, right? So let us declare I. Step 3 is we are going to declare I, or you can say it as set. In simple words, set I is equal to, what am I supposed to set it to, guys?
I plus 1.
Set I is equal to, what is my initial value of I supposed to be?
2.
Right? So I'm setting I to 2. Next, in the step 4, I'll check. What will I check? I'll check the condition whether I is less than n. What is I? I is 2. And
Less than
n
is equal to n or only less than, sir?
only less than. See,
Okay.
when you put equal to na,
Okay.
so when you do that, okay, let me tell that also. During looping, let's say I want to print 10 numbers. Okay, print first 10 numbers. This was good question. I will keep this in mind. Let us say I want to print first 10 numbers. What are those? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, this is my question. I'm supposed to print 10 numbers. So when I write a loop, moving forward, you'll understand what loops are. Okay. So basically what we do is we write the syntax is like for, you have braces, then we'll have conditions within them. Okay. There will be one initial condition. Let's say int I, we say it as integer I is equal to 0. And then we have We'll have one condition. I need to iterate until I'll have to do it how many times? Since there are 10 numbers, I'll have to iterate it 10 times to print each number. So since I'm starting with I as 0, okay, I'll take it as only less than, not less than equal to. You'll understand why less than, why I'm taking only less than. Okay.
Oh, won't it be 9? Because you said you are excluding 1.
See. For int I is equal to 0, I'm starting with I is 0, I is less than 10. So if it is less than 10, it will iterate only till 9. So the count, tell me what will be the count be? I'm starting with 0. Since I'm starting with 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and only 9. Okay, since it is less than 10. But you tell me what is the count. Count will be 1, 2, okay, 3,
10.
4, 5, 6, 7, 8, 9, 10. Okay. The count remains same. It remains same 10. But I am taking, since I have taken I have initiated it to 0, I will only take it as I less than 10. And while printing, what I will do is like within this condition, I will print or I will display whatever you want to say. What I will display is I will display I plus plus. Okay, this is a bit confusing. What I will do, I is 0. I is less than 10. Is 0 less than 10?
Yes.
0 less than 10. So what I'll do, I'll print I plus plus. That means
I plus 1. I is equal to
I
I plus 1.
plus I plus plus is nothing but I
I is equal to
equal to
I plus
I
1.
plus 1. So for the first time, what I will print? I'll print it as 0 plus 1 is 1. Right. Next, now I am incrementing I. You see here, the third condition. Okay. The first part of my for loop, you're going to understand this. This is the syntax. Okay. The first part of my for loop is initializing. The second part is condition, like until what condition should I run this loop? How many times should I repeat this? So that you are going to mention it here in the between. The last thing is what do you want to do? You want to increment or you want to decrement? Okay, that depends upon how you are going with the loop. So for the first time, I is 0, I less than 0, yes. So I'll come within the loop. I will increment I. Before incrementing, what I'll do, I'll print I. So I becomes 1. Next time when I go to the loop, I is already incremented, right? Instead of doing it I plus plus, I'll simply write I plus 1. Okay, 0 plus 1 is 1. Next time, I is 1 and 1 is less than 10. Yes. So what I'll do, I'll print it. 1 plus 1, I'll print it as 2. So this way, the loop will continue and finally we'll print 10. Okay. The main difference I want you to tell about only using less than 10. When can I use equal to 10? Okay. I can use equal to 10 when I am initializing I to 1.
I is equal to 1.
Okay. And I can put as equal to here because I'm right away starting from I. And this makes sense. What I can do, I can only print I. It will be simple. Nothing to do inside the loop. Just print I. See, I start with 1, I as 1 and I is less than or equal to 10. 1 is less than 10. Yes. So print 1. Next, second time, I is increment.
Increment 2.
I is 2. 2 is less than 10. Yes, print 2.
Yes.
Next time 3. 3 is less than 10. Print 3. Next 4. 4 is less than 10. Yes, 5 is less than 10. 6 is less than 10. 7 is less than 10. 8 is less than 10. 9 is less than 10. Finally, it comes to 10. When I is 10, 10 is less than or equal to 10. It is not less than, but it is equal to. So the condition will be true and hence we will print 10.
Okay.
Okay. So it depends upon how you are supposed to use it.
Sorry. What?
Okay. If I'm removing equal to sign from here, what I will do, I will go one step back. I will make I as 0 and I'll make it as I plus 1 since I should print from 1. Okay.
Sorry. What does I plus plus stand for?
You increment. Once one repetition is done, you increment the I value. Okay, you either need to increment or you need to decrement it.
Okay.
Okay, since you are going in a range, right? Let's suppose you want to start from 1 to 10. Okay, or 10 to 1, vice versa. You want to print it in the ulta order, reverse order. You initial as I to 10 and you make it as reverse, I greater than 10.
Oh, okay. Thank you.
If I is equal to 10 and equal to or greater than or equal to 10, you keep incrementing, you decrement I. Okay, let us see how we can print it in the reverse order. Start with 10, I is greater than or equal to 10. Next you decrement I. First time I is 10, 10 is equal to 10, you print 10. Next, second time, you're decrementing. Okay, you're reducing I. I becomes 9. 9 is greater than or equal to 10 now. So this condition will be less than. Okay. For this particular condition, it will print in the reverse order. 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay. I is 10. I is less than or equal to 10. Equal to 10. Print 10. Decrement 9. 9 is less than 10. Print 9. Okay. This way the loop will continue.
Why aren't we counting 0?
Where
When you used it in the reverse order.
0.
Yeah. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You stopped at 1.
Okay, so see, when I go to 1, I will be, what will be I? I less than or equal to 0.
Yeah.
0. 0 is less than 10. Yeah, so this will keep printing. So we need to alter our statement. This condition needs to be altered.
Okay.
Okay. Okay. We'll come back to it. Let us complete this step. We'll finish this one algorithm at least. Okay. So where were we? We are setting I to 1. We are taking input variable num. Okay. Next, we are supposed to repeat it until I less than n. Okay. We are not going beyond the number. We are not going beyond the number. Okay. If it is 29, we are going only at 28. If it is 11, we are going only till 10. For that reason, we'll have this condition. Until and unless I is less than n, we are going to repeat a few steps. Now, what are we supposed to do? You see this condition, right? We checked if the remainder is 0 or not. So that we'll use here. What we'll do, we'll check in the next step if okay, if this part, if this is equal to 0, then see, if you find any number, if num modulus I is equal to 0, then what does it mean? If it is divisible by any number other than 1 and itself, what does it mean? It means it is not a prime number, right? We'll go to step 7. Okay, because step 6 will be incrementing the value. Else go to step 6. Let me just pause it a bit. Okay, this is supposed to be our condition, and in 6 we are supposed to iterate I. We're supposed to iterate I. Finally, we'll have a decider step, which will decide whether if a number is prime or not. Okay, before going that, let us at least complete these steps. Okay, we'll take example as, let us take 6. Okay, I'm initializing number as 6. By default, what is I supposed to be? Can you people help me out? I should be initiated to 2. Just see the algorithm. I is supposed to be set to 2. Okay, so next we are done with first number. We have taken the input number as 6. We have set I to 2. Next, we'll repeat a few of these 5 and 6 steps until this condition satisfies. Okay, until I less than 5. Okay, let me make it a bit clear. Repeat step 5 and 6 until I less than 7. This will make more sense. Okay, we are supposed to repeat step 5 and 6 until this condition reaches out. So what is this condition tell? I less than n. I is 2. I is 2. 2 less than 6. Num is 6. Is 2 less than 6?
Yeah.
Yes. So now if 2 is less than 6, what am I supposed to do? I'm supposed to go to step 5 and 6. Right. So what does step 5 say? If num modulus
Increment.
num modulus I, number for step 5, first we'll go to step 5. There's a bit of disturbance. Okay, so num mod I, if it is equal to 0, we need to check this condition. We need to check this condition. Now tell me, what will we get? What will this give us? Num is 6. 6 mod 2 or 6 divided by 2. What will it give?
0.
0. 2 3s are 6. So it gives reminder as 0.
0.
So now what does our condition say? If it is equal to 0, I'm going to go to
Step 7.
So I'm skipping step 6. I'll go to step 7. In step 7, see, there are only 2 conditions, right?
Yes.
The result is supposed to be either the number can be prime or the number cannot be prime. It is a prime number or it is not a prime number. Right. So we'll have that here. In step 7, we'll check if. And I also told you, like, there is one extent until when we are going to loop. When I reaches n, that is number, okay, only until then we are going to loop. Okay, we are not using loop here. Okay, when we use for loops, that will become still easy. This is, like still we are in conditional statements. So understand that, keep that in mind. If I is equal to n, till when am I supposed to run my repetitions? I told you, right? Not exactly till 11, 1 less than 11. Not exactly till 29, 1 less than 29. That is up to 28, up to 10, right? So
Yes.
when I, that is when my iteration reaches n, when I becomes 28 or if number is 11 and I reaches 11. So at that time I will stop things. I will see if I is equal to n. If yes, then what I'll do is I'll print num is prime. That is I came through all of the iterations right from 2 to 11, but I did not get any number which is dividing my number. So I'd say it is prime. Else,
But
if the let's how your if and else conditions will execute is if condition fails, else will execute. Okay. If this condition is failing, I is equal to n is failing, then we'll enter into else statement. In else, we'll print the ulta, vice versa. That is, num is not prime. Num is not prime. Okay. So basically, this covers up our algorithm. Now let us execute it. So where were we? We were at the first iteration. That is,
I is equal to 0.
let us have it as like iteration 1. You will understand it better. First iteration. First iteration, I is equal to num is equal to, we were taken num as 6 and I is equal to 2.
2.
And what was our condition? Once we have set the number and I, we are going to repeat it until I less than n. I is I less than num, 2 less than 6. 2 less than 6. Yes.
Yes.
So what we'll do, we'll check if num modulus I is equal to 0. That is, we'll check if the remainder is 0. So what we'll do, 6 divided by 2, whether it is equal to 0. It is equal to 0, right?
Yeah.
Because 2 completely divides 6. 2 ones are 2 threes are 6.
2 3 are 6.
So this is also S. So if num modulus I is equal to 0, if this is yes, then what am I supposed to do? I'm supposed to go to step 7. What is step 7 say? If
I
I
is
is equal to n, I equal to n,
No.
I is 2, n is 6. They both are not equal. So
Yes.
I will go to else part and I will print. What will I print? I will print
If number is
6
not
is not a prime number. Right. In the first iteration itself, we got our answer that 6 is not a prime number. Let's suppose we take, okay, we take 9 as a number. I remains same, right? I is set to 2 by default. First condition is start. I read the input number as 9. I set I to 2. Step 4 is I'm going to repeat it until I less than n. So first I need to check condition is I less than n. I is 2. 2 less than n is 9. Is 2 less than 9?
Yes.
So if yes, what I will do is I'll come here. I'll check this condition. 9 modulus 2. Does it give me reminder 0?
No. Reminder is 1.
Reminder is 1. Reminder is 1. So what I will do? This is giving me as no. Reminder is not 0. So what am I supposed to go? See, if num is equal to 0, the reminder is 0, then I'm supposed to go to step 7. Else, what am I supposed to do? I'm
Step
supposed to go
6.
to step 6. What does step 6 say? Increment I.
Increment.
Just increment I. So in the next thing, my num remains same. Next iteration. Okay, we'll make it as one more iteration. See, this is how you will have to practice. These are simple algorithms. Okay. So this is easy, a bit easy. Iteration 2. Num remains same, but I is incremented now. Right?
3.
It becomes 3. And let me write the range also here. Since my input number is 9, what is my range supposed to be? From where to where am I supposed to, check?
1. 2 to 8.
2. We are ignoring 1. 2 to 8. Very good. 2, 3, 4, 5, 6, 7, and 8.
8.
Not beyond 8, right? So first time I is,
2.
see if I can put it here. Okay, first iteration I is 2, and I have this thing. Second time I becomes
3.
okay, I becomes 3. So here I is 3 because I am jumping from 2. I am going to 3 now. Since I did not find 2, if it is completely dividing my number, so I will go to next number. That is, I will shift to 3. I have
3.
implemented, that is I plus plus 3.
Yes.
Now check if 3 is less than 9.
Yes.
Okay, until this. Yes, 3 is less than 9.
9.
Now what I'll do, I'll check if it divides, if 3 divides 9. What is
Yes. Yes. This is 0. 3 3s are 9.
9 mod 3? 3 3s are 9. It
It's
gives me
0.
reminder as 0.
0.
So this is
Yes.
right. This is true. Since this is true, I will go to step 7. In step 7, I'll check if I is equal to n.
No.
Okay, I'll see if I is equal to n. I is 3. 3 is not
No.
equal to n. No.
No.
So if it is not, then else prime.
It's prime.
Means not
It's
is
not prime
is
number.
not prime. So 9 is also not a prime number. Right. So we took 2 iterations here. For the number 6, we had 1 iteration. For 9, we have 2 iterations. So
Yes.
it depends. Now let us suppose we'll take final example num, which is actually a prime number itself. Let us take 13. Okay. So for 13, I will range from 2 to
2 to 12.
10, 11, and 12. Okay. So my first iteration. First, this repetition is nothing but iteration. Okay. Until I less than n. So that until is nothing but this, what I've written here.
Yes.
I will be, first I will be 2. Next I will be 3. I will be 4. I will be 5. Okay. It depends upon how things go. So my number is 13. Okay. And I is 2. First thing I will check if I is less than n. I is 2. 2 is less than 11. Yes, 2 is less.
Yes.
So I will go to step 5. I will check if the remainder is 0 between these two things. I and num. I will check if 13 modulus 2. Remainder is 0. Is it 0?
No.
No, right? It is 1.
1.
So what I'll have to do? Since this
Yes.
fail, I'll have to go to else condition.
Else condition.
I'll go to step 6.
6.
I will iterate.
Increment the I.
I'll increment. From 2, I will go to 3 now.
3.
Okay. So now I is shifted to
3.
3. I is shifted to 3 now. So now second iteration, number remains same. 3 less than 13. Yes, 3 is less than 13. But does 3 divide 13 completely?
No.
The 3, no. Again, 3 4s are 12. It gives reminder as
1.
1. So this is a no. That means if it is no, then you go to else
Else
condition.
to step.
I have to increment I. That is, I'll have to go through even more iteration.
Iteration.
Okay. So that is iteration number 3. Let me say
3.
iteration number 3. Now I becomes
4.
4. Is I less than 13? Yes.
Yes.
I is less than 13. Then check for this condition.
Yes.
13 modulus 4.
Remainder is
4 ones are 4 3s are
remainder
12.
is 1.
Remainder is 1. Again, see, it does not give. I'll
No.
have to go to step 6.
Step 6.
Even here, I'll have to go to step 6. Even here, I'll have to go to step 6.
Step 6.
So one more iteration we'll have to do.
Yes.
That is supposed to be your iteration number 4. Iteration number 4, number is same, I is incremented to
5.
5. Now I is here 5. Is 5 less than 13? Yes, obviously 5 is
Yes.
less than 13. Now check if 5 divides 13.
No.
No, 5 ones are 5 twos are 10.
Remainder is
3
3.
is remainder. So it is not equal to 0.
Yes.
Okay. So
Go to
what I'll
go
have
to
to
step 6.
go to step 6 again. See, this way I'll keep repeating it. Okay.
Okay.
Keep repeating it, but finally, since we know that it is obviously it's a prime number, let us go to the final iteration. What is final iteration supposed to be?
12.
12, right? So when we are here at 12, is 12 less than 13? Yes,
Yes.
less than 13. Then check if 12 divides 13. No,
No.
12 ones are 12.
Remainder is 1.
Remainder is 1. If
Go to
what
step 6.
interests me to go to step 6. I'll go to step 6. I'll increment I.
I.
Now I becomes
13.
13. Okay, according to our algorithm, we'll come here. We'll see I less than n. So
No.
is I less than n? No, it is equal to.
It's equal.
So this condition is failing. So what we'll go is we'll directly go to step here. Step 7. Let us write that
Yes.
condition. Repeat this step. Okay, we can rewrite this condition as we'll check if I less than n. At the time you repeat step 5 and 6. We'll have else statement with this alongside this. Else, if this condition fails, okay, I less than n, we'll go to step 7. Go to step 7. This is how we are modifying it. Okay. When I is less, until and unless I is less than n, you keep repeating it. Now finally, it is not matching our condition.
Yes.
13 is not less than 13. So what we'll do? We'll go to step 7. In step 7, we'll check 13 is equal to 13. Yes, it is equal.
Yes.
So what we'll do? We'll print
Prime. It's a
number
prime
is
number.
fine. We'll print it's a prime number. So 13 is a prime number. This way, what you can do is you can cross verify. Okay, this is your algorithm to check if a number is prime. Now, one thing that you can do is the next time we come up with a class or a session, you see how can we like say if it is a small number, that is if it is 4 or if it is 6 or if it is 8 or 10 or 11, the number of iterations will be less, right? For 6 we saw it was only 1 iteration, for 9 we saw it was 2, for 11 it's going almost to 5 iterations, and as our number goes towards the positive side 100, what if I'm supposed to check for if this particular number 1,223 is a prime or not? How many iterations will I have to go? I'll have to go through 2 iterations less, that is 1 and itself. I'll have to leave 2 numbers, so I'll have to iterate it for how many numbers? 1 2 2 2 1 times, right? Because first thing is 1 range, first number is 1, last number is the number itself. Apart from these 2 things, I'll have to iterate these many times. This is time consuming, right?
Yes.
So one thing that you can do is you see, you go through, you refer internet and things, and what you can do, it's just kind of an assignment. What you can do is see how can we reduce the iterations. Do we really need to, like check until n? Do we really have to go right away starting from 2 to till last, till end? Or is there like any way that we can reduce it to half of it, or like reduce the number of steps? Efficient algorithm. This is not efficient one. This will give us whether number is prime or not. But this is it efficient. Okay.
Okay.
How did you get the reminders? Okay. See, this is a mod operator. We use a mod operator to get the reminder operator. mod operator. Let us have an example. Let's suppose I take 6 mod 2. What does this actually mean is, I'm dividing 6 by 2. 6 divided by 2. So what will it give? 2 ones are 2 threes are. What is the remainder? Like in your schools and all, you find the remainder,
Zero.
right? Let's sketch this. See. You will have 2 here. You will have 6. Okay. You will see 2 3 is a 6. The remainder is 0. Right. So the mod operator is supposed that will return, the mod operator will return you the remainder. Okay. Let's suppose we take 9 mod 3. Okay. So that will be like, you will have 9 here, 3 here, 3 3 is a 9. Okay. That will give you a reminder. Let's suppose let me erase this. You have 7 and you're trying to find the mod 7 mod 2. Okay. 7 mod of 2. 7 mod 2. So now 2, it does not divide 7. But what is the closest thing that we can go?
2 3s are 6.
2 3 is a. What is the remainder? 1. So this is the reminder that our mod operator will give us. When you write your code now, what you will do, you will write 7 mod 2. So that will return you. This will be equal to 1. That will only give you a reminder. If you have 9 mod 2, what will it return? If you have 9 here, if you have 9, what will it return? 2 4s are 8, right? 2 4s are 8. Remainder is again 1.
1.
So that way it will give you remainder as 1. Okay. So that is how you use the mod operator to find the reminders. The mod operator is definitely going to be used n number of times. Most cases we will be using during reverse. We have one more algorithm, right? Reverse of a given number. Even there we are supposed to use the mod operator. Okay, so let us wind up now. Let's continue more. So that is how you find the mod. And as I said, this is not the efficient algorithm. And I'll give you a hint here itself. Okay. See, if I divide this into exactly half, if I'm finding the prime, let's suppose I have 22. So what is my range supposed to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22. Right? The complete thing. From this we'll definitely eliminate 1, 9, 22. Now this I'll have to iterate these many times. First my I will be, okay, you're getting now what I actually means in our algorithm. Iterations. First time I will be 2, next it will be 3, 4, 5, 6, 7. Okay, so I'll have to loop how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Almost 20, 21 times I'll have to loop through this. what the efficient algorithm tells is, see, there is 2 here, right? If we divide it exactly into half, okay, let's suppose this is half of it. 22 by 2 is 22 divided by 2. What is half of 22? This is 11, right? So if I, divide it into 2 halves, you see 2. Do you find any multiple of 2 here? Any number which is divisible by 2?
12, 14,
12,
16,
12, 14, 16,
16,
18,
18, 20.
20. Right. Now, let me say, 22 mod 12. What will this give me?
Reminder is
12 ones are 12.
10. 10. Reminder is 10.
Reminder is 10. Right. It will give me reminder as 10. Next time again 10 mod 2. That will give me 0. What the algorithm says is, if you find any the beginning of the numbers, okay, right from 2 to 9, not even 11 also, if you can consider till 9, okay, you will have multiples of these numbers only in the coming front numbers. Like if you have 1 to 10, again when you have 11, 12, 13, 14, 15 and all, those are nothing but you are building it from the first 10 numbers itself, right? So if you have 2, obviously in the second half you will have some numbers which are divisible by 2. If you have 3, definitely you will have any numbers which are divisible by 3. See, 3 divides 15, 3 divides 18, 3 divides 21. Then definitely that number should also be divisible. Then 4, for 4 what do you have? You have 12, you have 16, you have 20. Right? These 3 numbers are divisible by 4. 5, you have 15 and you have 20. So basically what we do is, we reduce it equal to half. Instead of iterating to completely from right away starting from 2 to large but 1, we'll divide it into 2 halves. We'll only iterate to first half. If in the first half we did not get any number which is dividing 22, how can we get in the second half? You get my point?
Yes, yes.
If 2 cannot divide 22, how can, okay, see, what were the factors of 2 that we found out? For 2 from the second half, it was 12, 14, 16, 18,
20.
and 20. Now, 22 mod 2, what will be the remainder?
11. 11.
11.
0. Oh, yes. No,
11, right?
0, 0,
Reminder
0, 0.
0.
Remainder is 0.
So 22 is not a prime number, right?
Yes.
So let's suppose we take it as 19. Okay. So 19 by 2.
1. Remainder is 1.
Remainder is 1. It is not giving 0. So if 2 cannot divide 19 completely, this is the we should be 100% sure that 12, 14, 16, 18 and 20 will also not divide 19,
19, yes.
because these are factors of 2,
Yes.
right? Similarly, we'll see 3. What are the numbers that are factors of 3 from this range? We are taking 19 only, right? So the range will be from 2 to 18 if you are taking number as 19.
12.
12, 15,
15, 18.
3 mod 19 mod 3. What will this give me? 1.
The remainder is 1.
Was right? 3 is not dividing 19 completely. If
Yes.
3 cannot divide 19 completely, definitely If factors, that is 12, 15, 18, and also not divided. So you can skip 12, 15, 18. Similarly, here you skipped 12. In the first step, you skipped 12, 14, 16,
15,
18. Now in the second step, we are skipping 15, right?
Yes.
For this way, what we can do is, instead of checking for right away from I to n, we will check I to only half of the number. Okay, less than I less than n by 2, or basically simply you can add equal to sign also. In order, we are adding equal to include this number. Okay, so my range will be, if I'm supposed to check for 19, my range will be from I is equal to 2 to
2
2
18.
to 19 by 2. 19 by 2. What will 19 by 2 give me?
1.
No, not reminder, quotient.
Okay.
2, it will be somewhere around 2. 2 nines are 18.
Yes. 1 second.
So somewhere around 2 to 9. 2 to 9 or 2 to 10 you will have. What is better? To have from right away from 2 to 19 or 18, or 2 to 10?
Okay.
2 to 10. You will have lesser iterations. More fast your program will be executed. It will be more efficient. Okay. This is one adjustment that you need to do. You will not check completely, but you will only check half of the range. The range that you are supposed to take, you will just take half, so that the number of iterations will be less. Okay.
Okay.
I think it's time up. I've taken more time. Was this session useful, guys? One
Yes.
person.
Yes.
So,
Yes, of course.
okay, there's Aisha, Saad, and Uzma. Saad and Uzma, did you guys understand things?
Yes, sir.
Honestly, no, sir.
Okay. Okay then. If you guys have no doubts, then we can end the session. We still had two algorithms to cover: reverse and factorial of a number. Then we'll have Fibonacci series. Then we'll have palindrome. There are quite a few algorithms. We can cover up them in each session. Okay. So, what's the strength in the morning sessions, and why people are not joining in the evening sessions? Any idea?
Morning session is 9:30 to 11 o'clock.
Hmm. We'll have more strength there, right?
No, only 7, 8.
Only 7, 8 people is right. So it's the
Yes.
same. No worries. Those who want to learn, they attend sessions.
Okay.
Okay. And even in the morning sessions, Shreyab sir, it's definitely taking good sessions. It's covering up basic things.
Yes, yes.
Okay.
Excuse me, sir.
Yeah.
Sir, are you going to take the class of second algorithm to find the reverse of a given number in the morning session?
See, morning session, Shreyab sir is conducting classes. He's going in a different thing. He's covering up
Oh,
flow charts. Okay. He's going with flow charts. It's basically he's covering up flow charts. What we are executing here, he may be taking up different problems, but he will cover up things with flow charts. What we are doing here is we are going in a algorithmic way. Okay, in sentence wise, that is pictorial representation. Picture wise, Shreyab sir is conducting things, and he is also covering up basic syntax and all. I think he has covered up with variables and constants today, and basic if condition and all he has covered. Okay. So once even we, if we, after covering up a few algorithms, we'll start with Java syntax. Okay, specifically we'll start with Java, like what's Java, why we need Java, how is it
like
different
from the
other language.
basics of Java.
Yeah, right from the basics. If you do have your systems, we'll definitely install Java in our locals, setting up the environment variables, running up our first Java program. Then we'll start up with, basic syntaxes, variables, constants, basic operators. We have arithmetic operators, logical operators, then these conditions that we are writing here. These are nothing but conditional statements. If this condition fails, then you execute this. If this condition passes, then this is what you have to do. You repeat step 5 and 6. If this condition fails, this is what you have to do. So these are nothing but conditional statements. And thing that I told about you, the for loop and all. So those are iterations, loops. So these things all inshallah will cover up in further classes. Once we are done with covering up basic things, we'll go to advanced topics in Java, for what Java is known for. There's something called as encapsulation, polymorphism, abstraction, inheritance, objects and classes. These are what it makes Java one of the finest languages. Objects, classes, object-oriented programming. Okay, these are things that will fall in place as and we'll cover up things. Once we cover up basics, when you go to advanced sessions, there we'll learn about objects, classes, what's inheritance, what's abstraction, overloading, overriding methods. There are plenty of things. Okay. After that, maybe we'll have a few, like creating servlets. How do we contact with the servers? For that thing, we'll have servlets, applets, and then we'll have frameworks. At the end, like once you're ready with Java, you'll have frameworks to know. There are two frameworks which are Spring, Hibernate. These are Java frameworks that are being used in the industries to develop applications. So those are the frameworks.
Sir, excuse me, is Java and Python correlated with each other?
See, both have their pros and cons. Python is friendly language. It's just like how we speak English. The syntax is somewhat very much close to English language. The number of the syntax is quite easy. What in Java, what you have to do, like if there are 10 lines of statements, maybe in Python you'll have 3 to 4 statements. You can finish up things within 3 to 4 statements. So that is how Java is easy with respect to syntax. But when you go to business logic and according to your industry level, both they have their own pros and cons. Java is used in web application development. It's very vastly used in website developments. You have your Gmail, there and all front end React and all has been used, but back end you have CRUD operations where Java is basically being used. Most of your e-commerce websites and all, they are built by Java. They are built in Java. And Python, it is also used in as you know. It's used in machine learning, artificial intelligence, and all, creating models. In those fields, those scope, Python is best. There are things where you need to use Python, and there are things where you need to use Java. Okay. And one thing is, if you learn Java, definitely you will learn the other languages. That is how it goes. That's the advantage of using Java. Okay, there may be like you'll have 3-4 steps extra, but once you have a knack in this, the other languages are simple. You will learn. It's just like riding a bicycle, gear bike. If you know how to ride a more complex gear bike, R15 or I'm just giving you an example. Then definitely you will ride Splendor, those kind of simple vehicles, two-wheeler gear bikes you will ride. Okay, that's just an example. Okay, guys, I hope this session was useful. I took more time. see, along with the algorithm, we even covered like a few things, rules that we're supposed to know. The next algorithm, the next time we write algorithms, it will be easy. Maybe in next class we'll cover up 2 to 3 algorithms. Okay, basic things I've covered, like how to write an algorithm and how you iterate. You loop through each of the condition and you check whether it is yes or no. And my battery is running low. Okay, then we'll wind up the session, guys. Thanks for your
Thank you
cooperation.
so much.
Okay, and then tomorrow evening at the same time we'll connect back. Inform your group members also if others can join. It will be helpful. Okay, then, guys. Have a good night. And see you
Thank you.
tomorrow.
Thank you.
Yes.